Well, hello everyone. In the last episode, we talked about TCP communication and how this works. And in this episode, we're going to cover UDP communication instead. So basically, UDP is not that much different as to the implementation. On the server side, we're going to define a socket as we did in the TCP communication. But now we're going to use sock dgram instead of sock stream. Sock stream would give us a TCP socket, and dgram gives us a UDP socket. So now you're asking, I did the, yeah, all right. So now you may ask, why use UDP instead of TCP? Well, yes, TCP does, package integrity checks. So that means if we're sending a file, it makes sure that the file comes in the same way as it went out the host that sent it. But it's also a bit slower. So let's say for VPN or for games, for example, you want something that gets out the maximum speed when you don't need to have these integrity checks. So for instance, take a VPN. A VPN is a tunnel where you have a direct connection from a client to a host, and you're routing every traffic through this channel. So that means your HTTP request to google.com gets passed through this tunnel. And since HTTP is in fact a TCP connection, we already have this integrity check inside HTTP. So we don't need another layer that does these integrity checks. That would be just a waste of calculation and thus a waste of time. So instead, we use a UDP channel where it is, where it doesn't matter if packages get dropped or lost or something like that, because we already have this security of TCP. Same thing in games. If you're playing games, you let's say you're moving from point A to point B on your client. So what happens is your PC constantly sends some sort of keep alive signal or sends data to the server. Well, hey, I'm moving from A to B, and if your connection gets interrupted or something other happens, these packages won't come through. Which means you would be moving on your local machine, but for every other player, you would stand still at point A, where you stood at the moment your connection got interrupted. And if you get back online, the server would realize that in fact your client is telling him you're already at B, but the server knows you're at A, and then you get reset, and that's what we call a lag. So we have a UDP socket right here, and as for usual with all sockets, we have to bind this socket to a specific address. We're going to use the same as for TCP sockets, and we're going to choose the same port. And yeah, that's it for now. Let's swap to the client. For the client, we do the same thing, and now things are different from TCP. We don't have to do the connection thing. In TCP, we would now connect the socket to the address, and this is not necessary right now. So we are already at this point right now with just one line. So let's implement the server the server client we did the last time. So the first thing was the client sends an information to the server. That's what we're going to do right now. We're going to do s.send, and not send, but send to. And as you can see from the type hints, send takes just data and, some flags that don't matter for now. And send to takes the data, so the same thing, plus an extra address where the UDP packet should be sent to. And we're going to take that. So now we're going to use our data, hello server. And now we need the address. The address, as it's mentioned here, is a tuple or a union of an IP address, a string, and an integer. So we're gonna put in the address our server is listening, which is this one over here. Yeah, and that's it. So on this side we can just print s.receive from. And now we're taking the buffer size. Okay, and we're ready to go. So now start the client, and that's it. We got the message, and we got the connection where the data came from. So that's a bit different. In TCP, we had a client socket. Now in UDP, we use the general socket. It's like UDP is like the communist version of TCP. You have one socket and everyone can send to it, and yeah, you can receive from everyone, and you don't have to mess around with handshakes and permissions and stuff like that. You send it, and if the station receives it, that's great. And even greater if the message was received correctly. But if not, that's not the problem. And yeah, everyone can send everything to anybody. So now receive from is only used in UDP, and receive is only used in TCP. And that's because receive from gives us this this retrieving address. And of course the actual data that we send. So let's say message was received from, and the first element, because the last element, no, that's bad. Let's call it data, and let's save all of it. Or we could message and address, because we're getting a tuple here. So we have two values to unpack. So this one here has two values to unpack, and then we're gonna give it two variables. So we will unpack two values into two variables. That's right. So now we can say message equals message.decode. So now message is a string. Then we're gonna print message. No, we're not gonna do that. We're gonna print something for real. Message by, and now we're gonna get the address. And now we're gonna send something back. So now we're gonna use s.send2. Now the data, for the data we're gonna use your message was, wait, what the heck? Yeah, okay, it's 4 a.m. so that's why. Your message was message.encode. No, that's bullshit. Message dot end. What the hell? Dot encode, and now the address where the whole shit came from. So we're just gonna use the returning address that we got from the receive from. Yeah, and on this side we're gonna print as dot receive from what's simple buffer dot decode. This one gives the tuple, so we still have the returning address. We don't want it, we just want the data, so we take the first element of this tuple. Right, so run the server, run the client. Your message was hello server. Perfect. All right, and to be honest, that's all there is to UDP. That's I find it way simpler than TCP, because you don't have to mess around with handshakes. But the bad thing, of course, is you don't have package integrity checks. Meaning, well, although bit flips and stuff like that are quite, well, they can happen, and they do, because if you're transmitting on Wi-Fi or something like that, there is a lot of electromagnetic interference which can cause bit flips or something like that. And it's also, even via cable, it's best practice just to use TCP for. So every time you have the option of designing a known protocol and you have to choose between TCP and UDP. Please stick with TCP unless you know that you're building some kind of tunnel where you're tunneling a TCP protocol through a UDP socket, then use UDP for this socket, or you're gonna just stream data or audio or something that is. If you're streaming something, then it's always okay to use UDP. But instead, for commands and stuff like that, use TCP. Well, and that's all there is to UDP and TCP. These things are very, very basic and very simple in Python. If you put it in contrast to C or something like that. So in the next videos, we're gonna cover some more things like URLlib and API requests and HTTP requests. So tune in.